All right, and here's problem 3 off the spring 2016 Math 213 final exam. In this problem, I think for the whole problem we're dealing with triangles, or at least for the first half, specifically this similar triangles and congruent triangles. So the first one, we're supposed to decide if these are true or false and then justify, essentially. So the first statement, any two isosceles triangles are similar. That's a false statement. And what you need to know is that to be similar, triangles must have all their angles the same. So what I mean is you have two triangles and the three angles in one triangle each pair up with one of the three angles in the other triangle. So, okay, let me draw a picture. Two isosceles triangles. Here's an isosceles triangle where maybe, I don't know, this angle is 20 and this angle is 20. And therefore this angle is 140. And here is an isosceles triangle where this angle is, I don't know, 50, sure. And this angle is 50. And that makes this angle up here 80. These two triangles are not similar, even though they are both isosceles. So therefore, this is a false statement. Question 2, any two right triangles are similar. That's also a false statement. Because here is a right triangle. I need to draw these a little bigger so I can put the angles in there. Here is a right triangle. Sure, an isosceles right triangle, and therefore this angle is the same as this angle. They're both 45 degrees. And here is a right triangle where this is different than this guy. Sure. And therefore these two angles are not the same. So neither one is 45 degrees. So these triangles are not similar because there's a 45-degree angle here and there are no 45-degree angles anywhere in this triangle at all. So it's again another false statement. 3, any two isosceles right triangles are similar. That ends up being a true statement. And the logic here is that if you have a right triangle that is isosceles, this angle has to be 45, and these two angles have to be the same. Sorry, this angle has to be 90, and these two angles have to be the same. So 180 total degrees, use up 90 of them here. That leaves you 90 total here. So each of these guys are 45 degrees. And if this has to be 90, this has to be 45, this has to be 45, then the triangles are similar. So this is a true statement. Angle, 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 if you want. 4, if two isosceles triangles each have a 40-degree angle, then those triangles must be similar. That's a false statement. Here is an isosceles triangle where this is 40 and this is 40. And here is an isosceles triangle where this up here is 40. And these are the same. If these two are 40, that tells me that this is not drawn to scale. That tells me that this is 100 up here. And if this is 40, that tells me that these are both 70 down here. They're definitely not similar. That's a false statement. 5, if two right triangles have congruent hypotenuses, they must be congruent. That's a false statement. So here is a lot of false statements in here. Here is a right triangle with a hypotenuse of, I don't know, whatever. Maybe I'll just label that. And here is a right triangle and maybe that hypotenuse is the same length as that. But these clearly are not congruent. They're not even similar because these angles here, maybe they're each 45, are very different than these angles there and there. 6, if two isosceles triangles have a congruent side, then they must be congruent. That's another false statement. Let's see, here I could reuse that picture. It's an isosceles triangle. And its hypotenuse is, I'll label it with a 1. And then here is an isosceles triangle. And maybe this side length right here is the same as this guy here. So they have a congruent side, but they're clearly not congruent because this guy has a right angle and this guy does not. If you really want, I can label it like this. And we can see just by inspection that this is not a right angle. So therefore it's not congruent to this guy. For 7, I guess this is, if I'm using Roman numerals for whatever reason, if two equilateral triangles have a congruent side, then they must be congruent. That's a true statement. And you can use a lot of different theorems to prove that, but if you have equilateral triangles then all of their angles are the same. And if I have a congruent side, if any one of those sides is the same as any one of these sides, so maybe I pick this guy and this guy. Well, because these guys are equilateral, all three of these sides are the same, and all three of these sides are the same. Any theorem, so maybe I'll write by, and I could say side, 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 or side, angle, side, or angle, angle, side, or angle, side, angle, and I believe that is all of my congruence theorems that don't use the hypotenuse leg theorem. I don't have any 90-degree angles. And I don't want to put side, side, angle because that is not a congruency theorem. So by any of these guys, that works. Part B, this is a pretty tricky problem. You're playing pool and you want to hit the black 8 ball into the side pocket. In other words, this connects to right here. By banking the white cue ball off the far rail as illustrated below, if the table is 8 by 4 and the cue ball is 1 foot from the west rail and 1 foot, I think I changed that in the test. Maybe let's make this the east rail, because east is over here. And let's make this, oh no, sorry, it was right the way it was. It's the cue ball that I'm talking about. So this is 1 right here, and this is 1 right here. The table's 8 by 4. Cue ball is 1 and 1. How far south of the northeast corner, in other words, what's this length right here? How far south of this corner should I aim? So that's a lie. I want to figure out this right here. I want to aim at this point, and the question is, what should this be? So maybe this is x right here. And the idea with this problem is to recognize that you have similar triangles. Because the ball is going to bank off at the same angle that it came in at, this angle right here must be the exact same as this angle right here. And so if I draw this triangle, I have a right triangle, and if I label this as 1, maybe I can label this as 2. Note that up here I also have a right triangle. If I label this as 1, then this right here must be equal to 2. So if I go putting some names on these, maybe this is A, B, C, D, and E, I could say that triangle ABC is similar to, let's see, A is the vertex that corresponds with 2 marks, so that corresponds with the E. B is the 90-degree angle, so that corresponds with the D. And then by process of elimination, my last vertex is the C. I have ABC is similar to EDC. So if I want to figure out side length X, I can if I know some more information. Let's see, if this is 1 from here to here, and this whole thing is 8, that tells me that this is 7. And if this is 1 from here to here, I'd love to know what length this is right here. Well, if this is X, then this entire thing is 4 minus X. But one of them is used up over here, so this would be 3 minus X. Right? It's 3 from here to here, all the way from B to D. But X of them are used up here, so 3 minus X of them are used up over here. The last fact that I need is that this is a side pocket, so it's right in the middle, so therefore this side length right here is 4. So I can use this 7, this 4, this X, and this 3 minus X to set up proportions. I can say that, let's see, if I want to solve for X maybe, X is the length from C to D. So if I put that on top on this side, then I would want the length from B to C to be down on the, or to be up on the top on the left side, so that's my 3 minus X. So here is DC and here is BC, and then maybe I'll take X and divide it by the 4. That's length DE. So I have to divide by length AB over here, which is exactly 7. And if I could solve this equation, I could figure out what X is. Well, if I cross multiply, I get 4 times 3 minus X is equal to 7X. So 12 minus 4X equals 7X. So if I add 4X to both sides, I get 12 equals 11X. Oh man, that crashed at a really annoying time, but I think I left off, I said 12 equals 11X. So if I divide, I hope that's what I left off at. So if I divide both sides by 11, I get that X is equal to 12/11. X was this distance right here, which was exactly what the question was asking for. So my answer would be 12/11 of a foot, if you really care about units.